This is Babak. In this video I am going to solve the following problem for you. Evaluate the following integral. So here we have an indefinite integral. We are supposed to evaluate this indefinite integral. I would recommend you to pause the video at this point and try to solve this problem yourself first. As a hint, this problem is much simpler than it seems. One possible answer would be I equals to minus 1 over 1 plus tangent cube of x. Okay, now let us solve the problem. The first thing that I did actually when I wanted to solve the problem, I simplified the denominator a little bit. If you see, I can take these two and factor a sine squared out. I can take these two and factor a cosine squared out. Okay, so let us just simplify the denominator a little bit. So this expression inside these brackets, I will simplify that one first. So this I will take sine squared out from the first two terms as I mentioned. So sine cubed from the first term is left, cosine cubed from the second term. And if I factor a cosine squared out, it becomes cosine squared, and then I will have sine cubed again, x, plus cosine cubed, x. And then it is clear that I can factor this sine cubed plus cosine cubed out, and what is left from the first one is sine squared x plus cosine squared x. But of course, sine squared x plus cosine squared x is the famous trigonometric identity that's equal to 1. Then what I get is sine cubed x plus cosine cubed x. So then the integral that I am looking for becomes the integral. The numerator, I just keep it as it is for the time being, of course. And the denominator becomes simply sine cubed x plus cosine cubed x, but of course I have a power of 2, then I will have dx. So the next thing that I will do, I will keep the numerator as it is, but in the denominator I factor a cosine cubed out, so then it becomes sine cubed divided by cosine cubed and then plus 1. All of it is inside the pair of brackets in a squared. Yes, so what I have done, I have written this expression instead of what is inside, and that's clear because if you multiply this back, cosine and cosine cubed and cosine cubed are gone, so you will have sine cubed, and then cosine cubed times 1 is that one. So what I have done is completely correct. But of course this has a better name. I can call it tangent cubed, and this cosine to the power of 3 raised to another power of 2, it becomes cosine to the power of 6. So this becomes the integral 3 times sine squared x cosine squared x, and then I have this cosine to the power of 6x, and then I have tangent cubed x plus 1 squared dx. Then I can simplify two of these cosines with, so this cosine squared with two of them here. So what is left for me is cosine to the 4x. And then let me just write it in two steps. So it becomes 3 sine squared x. In the denominator I will have cosine to the power of 4, but instead of cosine to the power of 4 I will write it as cosine to power 2 cosine to power 2, and then I have 1 plus tangent cubed x squared. Okay, and then I will have dx in front. The reason that I did it like this, because I want to take these two together and write it tangent squared x. Okay, so then it becomes the integral of 3 tangent squared x, and in the denominator I will have cosine 1 cosine squared is left, and then I will have 1 plus tangent cubed x squared dx. Okay, now what I can do is to use the substitution method. So what I do, I will take 1 plus tangent to the top power of 3x to be u, and then I differentiate both sides. So the left hand side becomes 3 tangent squared x multiplied by the derivative of tangent x according to the chain rule dx, and on the right hand side I will have du. But we know that the derivative of tangent is 1 over cosine squared, so it becomes 3 tangent squared x divided by cosine squared x, and then dx in front is equal to du. So this means that this part is nothing except du, and this part is u squared. So then this integral becomes the integral of du divided by u squared, but this is a famous integral, so it becomes minus 1 over u plus a constant. Then I will replace u with its expression in terms of x. Then I will get the answer which is provided in the problem itself. Okay, so I hope that you enjoyed the problem. I will put the link to the PDF file of these notes below the video in the descriptions. Until the next video, be safe and goodbye.